Welcome you all, myself Nagarajan, Assistant Professor in Department of EC at Rohini College of Engineering and Technology. In this video, let us see the optical communication third unit topic, light source material. Let us see the light source materials. Of this video, the student will be able to understand the light source materials. Let us see the light source materials. The spontaneous emission due to the carrier recombination is called electroluminescence. To encourage electroluminescence, it is necessary to select an appropriate semiconductor material. The semiconducting, depending on energy band gap, can be categorized into direct band gap semiconductors, indirect band gap semiconductor. In direct band gap semiconductors is the gallium arsenide, indirect band gap semiconductors silicon. Some commonly used band gap semiconductors are shown in table: gallium arsenide and silicon. Energy band gap is a direct 1.43, recombination is 7.21. Now the direct band gap semiconductors are most useful for this purpose. In direct band gap semiconductors, the electrons and holes on either side of band gap have some value of crystal momentum. Hence, direct recombination is possible. The recombination occurs within 10 power 8 to 10 power minus 10. In indirect band gap semiconductor, the maximum and minimum energies occur at different values of crystal moment. The recombination in this semiconductor is quite slow. The active layer semiconductor material must have a direct band gap. In direct band gap semiconductor, the electrons and holes can recombine directly without need of third particle to conserve momentum. In this material, the optical radiation is sufficiently high. These materials are compounds of group 3 element and group 4 element. Some tertiary alloys are also used. Emission spectrum of gallium arsenide, the LED is shown in figure and upcoming next slide. The peak output power is obtained to 810 nanometer. The width emission spectrum and the half power is referred to as a full width half maximum spectral width. This is a spectrum wavelength. The fundamental quantum mechanical relation between the gap energy and frequency is given as E is equal to h b and lambda is equal to hc divided by E, where energy is a joules and wavelength is a meters, expressing the gap energy in electron volts and wavelength in micrometers for this application. So lambda is equal to 1.25 Eg electron volt. Different materials and alloys have different band gap energies, and the band gap energy can be controlled by two composition parameters x and y within the direct band gap region. Two expressions relating Eg and xy are: Eg is equal to 1.424 plus 1.266 x plus 0.266 x square, and another one expression is the 1.35 minus 0.72 y plus 0.12. And I hope that all of you understood about this video. Thank you, dear students.